City, by the way. I wrote a lot of these things. So many people have asked me why. Why did Altair decide to develop a bus? And the reason's actually very simple. I was looking for a stretch project for our engineering group, and I had just read the book Competing for the Future. And the concept of developing a next generation city bus looked like just a great challenge, just the right opportunity. An opportunity to demonstrate our technology and design process, as well as our people's passion and innovation while creating something which was relevant to society. So we're very, very excited about how this has really turned out. Pretty good, huh? The program goals were to lower the total cost of ownership and to lower the oil dependency and emissions. And the resulting initial design was extremely good and attracted some pretty high interest. So Altair partnered with Automation Alley, who is here, not up here I guess, with Automation Alley and sought funding to take the program to a demonstration phase. In 2005, we won an FTA grant with the help of the Michigan delegation, many of whom are represented here today, especially Congressman Joe Nolenberg. I don't know if Joe is here today, but Joe was really a lot of the energy for us, and we appreciated that. And later, Congressman Gary Peters, as well as Senators Stabenow and Levin. The program has received a total of $5.1 million from the FTA. Many thanks to Walt Kulik and Marcel Bellinger of the FTA for their support and program guidance. Those guys are here today as well. We're so happy to have them. I also want to acknowledge the support and funding from Automation Alley and the MEDC. Thank you, Ken Rogers, very much. And thank you to Martin Dover of the MEDC, who's representing them today. It's essential to recognize the importance of federal and state government investments in R&D to spur economic growth and foster innovation. And Altair is an innovation company. We have a number of kind of crazy projects. I didn't say that when I said why did we develop a bus because we're crazy. But we do have a lot of crazy projects, and we have partnered in a couple of them with the government. And it's just been fantastic for us. So I also want to acknowledge our supplier sponsors and the partners who donated components, time, and expertise. Our two platinum sponsors were Parker Hannafin for support above and beyond the hybrid hydraulic system. They've been just marvelous on this project, just great to work with. And Meritor for their driveline contributions. And our three gold sponsors were Meritor, Wabco, Prawn, and Sika. Thanks also to the many silver sponsors noted in the slide shown. Somewhere, there's the slide shown. So they've all been terrific to work with through this program, and the guys have just enjoyed all those relationships. And also to the partners at DDOT and especially SMART for their ongoing participation and advice throughout the program. So finally, before I have Mike Heskett come up and tell you more about the bus and the details on the bus, I'd like to have the bus team stand up and be recognized. Some of them are already standing. I have to say that the way this bus came together is just a reflection of the unbelievable talent of especially the leaders, Tim and Jeff. But just the whole team is just a phenomenal team, as are most of the people inside of Altair. I just have great people working here. So finally, let me bring Mike Heskett on. Mike is the Chief Operating Officer of Altair Product Design. And in addition to running our global services business, we're in 16 countries with over 500 people in his team. He has personally shepherded this project every step of the way, and I do mean that. So Mike, please come up and give us a bit of background on the bus design and evolution.
Thank you, Jim. So Jim, he covered the bus program. What I want to talk about is the bus itself. And to start with, there's a couple things that Altair Product Design is really well known for. And two of them that really stand out is our optimization technologies and experience, as well as our vehicle engineering. So I wanted to show you a couple examples of how these contributed to the way this product finally finally turned out, and then get more into the actual results from the bus. So first, to do this, I wanted to introduce some technology to you. Altair OptiStruct is actually technology that we provide commercially, and it helps you to actually decide where best to put material in your structure. And it works kind of like some of the natural processes. If you look at the way your bones grow, bones grow where there's load and stress, and where there's no load, the material is actually dissolved and removed. So these actually works in the same processes that follows something like bone growth, and it helps an engineer decide where should I put the material. So a very simple example on the screen just shows a simple truss, gives you an idea how that works. Now obviously we apply this to very complex systems, everything from consumer products to vehicles to aircraft, and we apply this to our bus design. And you'll see some of the structure when you look inside the bus, but a lot of it's covered up. But in the end, this is the structure underneath. And you'll see a very tailored and very optimized pattern for all the members in this bus. And actually there's out here on one of the tables, there's a little scale model if you want to look closer. So using the optimization methods, we figure out the best place to put it. And then finally we decide what materials to use. And this bus, we actually used aluminum materials, aluminum extrusions specifically, and there's a few reasons for that. You can take extrusions and make very complex shapes out of it, and actually combine a lot of the features and functions you need. It simplifies your assembly process, gives you better quality control, you got very good dimensional stability, and also the tooling costs are very, very low, so that offsets a lot of the material costs. So with this bus, and with this construction method, in the end, we ended up below 26,000 pounds per curb weight. And that's actually very light. So that's 15% lighter than most of the hybrid buses out there. And it's actually even 10% lighter than a lot of the non-hybrid buses. So weight savings for vehicles is critical for your fuel economy later. And this was a big part of this program, is to make it the lightest vehicle possible. The other thing I mentioned was system engineering. It was very important for us not just to make a demonstrator that you could show a technology. It needs to be a production solution that's good for the transit industry. So we applied our system engineering to every system that was critical. And I just want to show you one example of that. So, okay, here's a picture that you don't want in your city, in your transit. You don't want to have road calls caused by your cooling system overheating. And so our goal in one of these system engineering analyses was to take a look at the cooling system and avoid this situation. Avoid road calls, avoid unscheduled maintenance due to the cooling system. So we really looked at the whole cooling system and said, how can we design this more efficiently? So the very first thing we did, actually the radiator in this bus is 50% larger than most radiators out there. We made it 50% larger, but we also made it half as thick. And if you think about heat transfer, the air going through a radiator core, by the time it's halfway through, that air is pretty warm. So you aren't getting much heat transfer on the last part. So by making it larger and thinner, we save 25% of the mass, but we actually make it more efficient for thermal cooling. So in this way, we saved weight. We also pull air from the top of the bus. This is where the source for your coolest, cleanest air. A lot of buses will actually pull air down by the curb where it's very hot, there's a lot of dust and debris. So we made sure that we pulled the air in from the coolest, cleanest place we could, control it through this cool air corridor, and supply better performance. The last thing about this is we used a bank of electric fans. You can turn them on and off individually, and that really allows us to tailor your electrical load versus your need for cooling. So in this way, we reduce the electrical load on the engine, and that makes the fuel economy even better. Okay, so that was just one example. We can pick almost any system, and I could give you stories like this, but I wanted to give you an idea of the system engineering. So next, let's talk about the hybrid, okay? When you look at making a vehicle hybrid, you really have to pick the right technology. One answer is not correct for all vehicles. So for a transit bus, you have a very heavy vehicle, You have a lot of starts and stops and a low speed in between those stops. So those conditions drove us to, as we assess all the different hybrid technologies out there, finally to determine the best technology to use is a series hydraulic hybrid. And there's a few reasons for this. So one is that it has very high power density. When you brake, you can capture a lot of that energy very quickly. We can actually return about 70% of our energy back to the wheels after a stopping event. So you can get back to about 70% of your speed with no engine on at all. Besides that, you actually have lower costs. So lower cost to enter, lower lifetime costs, I'll talk about in a minute. And it's also proven technology. These pumps and motors are out there in all the construction equipment and off-road equipment you see. So these have been around a long time, very durable, very good technology. So the series hydraulic hybrid, just to give you a look at how that works. So as you're braking, the two pumps that are hooked to the wheels will pressurize the tanks. You can see in the red tanks being pressurized. Then it uses that high pressure, runs it back through those same pumps, that they turn into motors and they drive the vehicle. In the meantime, the engine can run, it's got a pump on it, it can maintain a pressure or even drive it in a hydrostatic state. Okay, so that's kind of how it works. The next step was knowing which technology we wanted. We looked at who could actually supply that technology. We really assessed all the players in this market, and it became very clear that Parker Hannifin was in the best place to support us. They not only had very good experience in different vehicles like refuse vehicles and panel trucks, but they also were much closer to being production ready, being able to support a production program. So what you see on the screen now is actually the hydraulic system that's integrated into the powertrain. You see the yellow pumps and motors in between the engine and the axle. This shows where we've packaged our high pressure and low pressure tanks. Just basically integrated that inside the vehicle powertrain. In hindsight, as Jim mentioned, I also want to thank Parker. They've been excellent to work with and very competent and good partners on this. Okay, so what? You got a light vehicle, you got a hybrid. What's that mean? So now we talk about the results. And one of the most important things is the fuel economy from a vehicle like this. And I guess at this point I want to caution everybody, if you hear someone say a fuel economy, you have to ask a couple questions. What kind of vehicle is it? What's the size? And how's it driven? Because unless you're doing this exactly the same, you don't have good comparisons between vehicles. So when we did our fuel economy testing, we were very careful to follow closely the protocols the FTA has set up to do all the fuel economy testing at their Altoona bus test center. So we did this testing up at the Michigan Proving Grounds here. We set up the same course and followed that test program very closely. So our results from that test was 6.9 miles per gallon, averaged over 3 different duty cycles, a downtown central business duty cycle, a commuter, and an arterial. So that's following the same protocol that the FTA uses. And what's important about that is that allows you to compare the results to other buses that have been tested, and that's in the FTA database. So comparing this to the diesel buses of the same class, the 40-foot heavy duty, they average about 3.3, so we're more than twice as fuel efficient as a basic diesel bus. And even scanning through and looking at some of the best electric hybrids out there, this is 30% better than those. So these are very significant fuel economy results. But the one thing is, even that isn't so important if you can't make a good business case for it. So actually the next slide, I think, is by far the most compelling story about this. What you see up here is a life cycle cost chart for various options. On the left is compressed natural gas. The next one going to the right is diesel. The next one is electric hybrid. And then finally, the hydraulic hybrid. And if you look at, there's been many transit authorities out there buying electric hybrid buses. They're being good citizens. They're trying to reduce their dependency on oil and lower emissions, but they're paying a lot to do this. They're paying extra to do this. Finally, here's a choice where transit authority can make those decisions and actually save money too. So compared to, an electric hybrid fleet choice, if you're going to buy 100 buses for your fleet, you're going to spend $25 million more over the life of those buses than you would with the hydraulic hybrid. And even just comparing to a diesel fleet, if you're replacing your diesel fleet, you can save $15 million for every 100 buses in your fleet too. So this is an extremely compelling story that finally you can be a good citizen, have lower emissions, decrease your dependency on oil, and save money while doing it. Okay, so that just summarizes what I wanted to show you. I want to show you enough details about the bus so you understood why this was important, why this is exciting. And summarize again, here's an option with better fuel economy, lower emissions, and still saves you money. It's a lower life cycle cost than any other choice out there.